after the event as well. Please keep your audio muted in order to avoid any background or distracting noise. And when we offer our Q&A session, you are welcome to type a question in the chat feature. Now I'd like to introduce our presenter today, Dr. James Eagan. Dr. Eagan is an assistant professor in the School of Polymer Science and Polymer Engineering at the University of Akron. He graduated from Emory University with a BS in chemistry and received his Ph.D. from Columbia University. He conducted postdoctoral studies at Cornell and worked as a lab scientist at Aramco prior to joining the University of Akron. He is the co-founder of Exsponse Inc., director of chemistry for Ascribe Bioscience, and is the recipient of the AAAS 2017 Newcomb Cleveland Prize. His group's research at the University of Akron investigates how plastics can be deployed pragmatically to address the needs of today without compromising the future. So please welcome Dr. Eagan.
Thanks, Billy. That last part there, addressing the needs of today without compromising the future. That is really why we're here. That is the definition of sustainability. And so how do we address these needs? How do we avoid compromising the future in this modern era? Because our modern era is very complicated, right? And so the devices we're talking to are very complicated. The electronic infrastructure, even our water, our food supply, our energy, everything is so complex. And these complexities come with a lot of give and take. And so when we want to make the right decisions, sustainably speaking, we really need to understand a lot of these complexities. And plastic is a material that really captures all of those complexities, the good and the bad, unlike many other materials. And so in Northeast Ohio, we are a large consumer and producer of plastic. At the university, we are a leading research institution in plastic. But we have a problem. We have plastic pollution covering just about every square inch of our globe. It's on the sea floor, it's on the water surface, it's in landfills. We have a real problem. And as a result, plastic is turning into a four-letter word, right? And as someone who has studied these materials for a decade, it really hurts to see such a powerful and useful material get lumped in to such a bad categorization, right? So plastic is about to become as fashionable as smoking. But if you look at the last year, plastics have been vital to maintaining hygienic environments, in dealing with a global pandemic. The face shield is plastic. The foam cushioning is plastic. The elastic is plastic. The number of these masks that have snapped for us, right? It's so frustrating when you have a poor adhesive or not a good elastomer. Those are plastic materials. And our understanding and usefulness of these materials is what makes this possible. All the way from the glasses to the filter in the mask to the protective single-use equipment. All of these are single-use plastics that are critical to our society. And so there's yin and there's yang. There are good things that plastics bring to our society that we absolutely want to maintain, and we need to understand and recognize those. But at the same time, we have to balance them against these environmental pollutions and the health consequences and burdens that come with this pollution lifestyle. So I'm going to talk about these two areas here. And I'm also going to talk about something that is very important for sustainability, and it's not to get distracted by the problem that we see. I concede plastic. I hate plastic pollution. We all don't like the pollution that plastic brings to our environment. But there are orders of magnitude worse pollutants that are existentially threatening our society that are invisible, all right? And so when we look at this picture, yeah, there's trash in the ocean, right? It's very upsetting. I wouldn't want to surf this wave. But do we understand the benefits of this polyurethane surfboard coated in an epoxy polymer plastic resin. His swim trunks are polyurethane, polyester. They probably have a little bit of polyethylene in there too to help wick away the moisture. I saw that even our university photographer was in the call today. The camera that's taking this picture to keep it waterproof, the body itself, the manufacturing of the lens and the detector, all of these are plastic materials that we benefit from. So how do we balance the environmental costs? Plastics are modern materials. You cannot build a wind turbine without a carbon fiber reinforced plastic. I see Joe Men is in the call too. This student does research on how to develop composites that can be used in these sorts of applications. These are vital materials to developing sustainable energy sources. A vehicle is a very heavy object, but by replacing traditional materials with lightweight plastics, you can reduce the mass and up to double the fuel efficiency by using lightweight plastic materials. This university and Akron as a whole, we are really lumped into the tire and the rubber industry. These are plastics, these are polymers, and understanding how these materials behave allows us to increase fuel efficiency even further. Even at the grocery store, a cucumber will last about 3 to 4 days on a grocery store shelf before it starts to produce ethylene, it over-ripens, and it spoils other vegetables and fruits around it. By wrapping it in a single-use plastic packaging, it can prolong the life of the cucumber for up to 2 to 3 weeks, reducing food wasted, etc. So we need materials. We need these plastic materials. And the problem is that most of it, or a significant portion of it, is used in single-use plastic packaging. This is the disease, that we use something for maybe days, weeks if we're lucky. If you consider the entire production process, maybe a year. That's how long we use the material that is then going to last in the environment for centuries. That use time and that end of lifetime are completely disproportionate, right? That's the problem. And I understand why plastics would be considered as a bad toxic material. If you go to Thanksgiving and you spend half your time arguing and fighting with your family, you're going to think of Thanksgiving pretty negatively. You might not enjoy the other half of the material, right? And so these materials are only single use if we let them be, all right? And so we've been told since we were young for decades, reduce, reuse, recycle. We need to remember that it's in that order, all right? Reduce the amount of plastic you use, reuse it yourself if possible, and the last option is to recycle it. So take pride not in, oh, I recycle all my bottles. Take pride in how little you use in your single-use plastic. As an economic perspective, we think of the supply chain and the products as ending with the consumer. My product was purchased. Both the consumers and the manufacturers need to appreciate that materials do not disappear once they've been used. And so this is what our breakdown of end of life looks like. Most of our materials leak into the environment or they are landfilled. This is according to a 2016 report on single-use plastic packaging. We collect about 30% of it. And of that 30% that is quote unquote recycled, we incinerate half of it. That seems kind of jarring, right? We're burning our trash. But keep in mind, we're not burning it just to make it disappear. We're burning it for energy. We make plastic from natural gas. We make it from fossil fuels that we were going to burn anyways. And so plastics are giving an intermittent life before the incineration, where we recover the energy that's in the material. I agree, though, this is far from ideal, right? We should be recycling the materials, processing them into new objects. Of the 14% that we recycle, most of that, about 13% of it, is downcycled. We'll make it into plastic lumber or composites, or maybe we'll grind it up and sprinkle it into the astroturf, those little black bits at the bottom of the artificial turf, right? It's only this one tiny little sliver, this green sliver here, that is actually reused in equal value products, okay? So why is that? So this is a picture I took last year at my local Giant Eagle. Now let's take a step back from plastics and just talk about recycling in general. Even very recyclable materials like paper, right? With paper products, you collect the waste, you break it down by the addition of fresh water and acid to regenerate the pulp, and you can reprocess it into new paper products. So this is March 13th last year. If you remember March 13th, it felt like the world was coming to an end. It was the apocalypse. You go to the grocery store and everyone was just hoarding the paper towels, the toilet paper, canned foods. It was chaos. And this is at my local aisle, and I just had to take this picture. They're completely sold out of paper towels except for the recycled materials. These are full stock. Why is this? Because it's a little scratchy. The paper towels aren't quite as absorbent as the virgin material. Recycled materials don't perform as well as virgin materials. So even in the end of the world scenario, doomsday preppers say, I don't need this recycled material, right? I'm going to hoard the good stuff. So let's go back to plastics. We need to understand that not all plastics are the same, right? So what are these little arrows here? The numbers are meant to be more accessible for the public, right? They're telling us what the plastics are. As a polymer scientist and a chemist, I find much more meaning in these structures, right? But I understand that this looks like, hieroglyphics to most people in the public, right? I don't know what all these squiggles are. To me, though, this tells me a lot about what the materials are, as well as how they're going to behave. Because if you have a different chemical structure, you get different properties. So you can have stiff, rigid piping, or thin, strong film, clear plastic, Tupperware, which is stiff, et cetera, right? So we can access and fine-tune the properties by using the different numbered plastics that are so common. So plastic 1, 2, 3, 4, 5, 6 is easier than telling somebody, oh, it's made out of isotactic polypropylene or polyethylene terephthalate, which is a bit of a mouthful. But that identification code is exactly that. It is just an identification code. It is not a recycling symbol. Wait, what? The chasing arrows with the number inside of it does not mean that that material is recyclable. It is only an identifier. This was established in 1988 by the SPI in order to try and clarify what the different resins were. It was changed to a triangle in 2013 because they realized, hey, this is pretty confusing, but this really hasn't been adopted. And there are a lot of investigative reports into exactly how this came about and why this is. I'm not going to go into that here now, but I just want to emphasize that this symbol does not mean this symbol. So when you do put it in the recycling bin and it gets picked up, what happens next? Hey, we have single stream recycling. That means it can handle all the different numbers, even if they're not recyclable, right? Single stream really just means that there are some sorting capabilities. So when the truck comes, picks up your garbage, throws it into the back, it takes it to a facility like this. This is the first machine. It is a rotating gears which sort based on weight. So the lighter materials float up these gears. The heavier materials like cardboard and glass are going to fall through, and we're going to repeat this. And so we sort by weight first. This gets to the first thing that you can do to help improve recycling. Don't throw plastic bags in there. Plastic bags are essentially films that will wrap around these gears. They're going to grind the machine to a halt. And every couple hours or so, they have to shut down the entire operation. And individuals have to go climb in here, and the workers have to pull out the plastic bags to unclog the gears. I think of this as if you haven't vacuumed your apartment for a long time and you finally get around to it and the gears get all clogged with hair, that's what the plastic bags are doing. If you're really into rock climbing and sustainability, you could probably find a really enjoyable job at a recycling facility because you get equipped with the carabiner and they send you up and you're climbing all over this machine, pulling out the plastic bags. But that's hazardous work. It's costly work. Shutting down the equipment for hours on end really costs recycling facilities a lot of money. So don't put your plastic bags in here. The next step after the sorting by weight is sorting by composition. So this is a video of a conveyor belt with lots of waste on it. And what's happening is there are air jets at the end of this conveyor belt that are launching the plastic up in the air or letting it fall over or under this divider here. What this beam of light is known as an infrared spectrometer. It's a method for identifying the composition of the plastic because the plastic interacts with the light in a specific manner. So this allows the machine to identify, is this plastic number 1 or is this plastic number 2? And then it knows the speed, the location, and it uses these air jets to then sort out the plastic. This is a real-time video, so this machine is extremely high throughput. It's very fast, but it's not perfect. And you can do this several times over. And this gets to a technical challenge that I would like to talk about because my group in particular is very interested in this. That infrared light, it's really good at identifying plastic number 1, which is PET. And so your water bottles, your Gatorade bottles, we're really good at recycling those. Absolutely recycle your water bottles that are made from plastic number 1. But plastic number 2, plastic number 4, plastic number 5, those are polyolefins, polyethylene and isotactic polypropylene. And these two materials are the most abundant plastics in the world that we produce. You can see that since we discovered them in around World War II, their production has skyrocketed exponentially. The only hiccup is really the 2009 recession. And even then, it's just a dent. So we produce these materials on the hundreds of millions of tons per year scale. And although they have different numbers, chemically, they are very, very similar. These are just carbon and hydrogen. And as a result, that infrared light is not very efficient at sorting these two materials from each other. So they typically end up mixed together. And if you don't sort these out perfectly, the recycler is going to take them, they're going to melt them down, push them into a new material, and you end up with a polymer blend. And what's important here is that polymer blends form phase-separated mixtures. Now, I realize I'm talking science gibberish at this moment, but you've seen phase separation. Phase separation is your salad dressing vinaigrette, oil and vinegar. These phase separate, right? You have your oil on top and your vinegar goes to the bottom. Polymers do the exact same thing. And what's important is that every plastic phase separates from other plastics. Okay, so what if they phase separate? What does this mean? What this means is that if your milk jug and your yogurt cup end up together in a recycling facility, and we melt them down and we process them into a blend, you get something like this. This is an actual polyolefin recycled blend. And as you can see, it's very brittle, right? This isn't really good for anything other than making lumber or maybe some downcycled grind that you would put into AstroTurf. So we downcycle it because the mechanical properties aren't there. So what my group investigates is, can we develop additives that you would add, sprinkle in, say, 1 weight% of what we call a compatibilizer. And that compatibilizer then enhances the mechanical properties. It stabilizes the blend and improves both the mechanical properties, but most importantly, the value of the plastic. Can we help our recyclers become profitable? That is a key objective. So how can we help our recyclers be profitable? Man, are all these numbers and all this information, is it just too hard to recycle in your curbside? So I'm going to try to give you some guiding principles. First and foremost, what's the shape of the object? All right, if it's a molded object, absolutely, recycle it. It's easy to recycle Gatorade, water bottles, and milk jugs. We're really good at it. Films are terrible. Don't try to recycle plastic film from what got shipped to you. Don't try to recycle plastic bags in your curbside recycling bin. These are going to tie up the gears. Then you can ask yourself, okay, what is this material made out of? And it's as easy as 1 and 2. Plastics 1 and plastics 2 are recycled almost everywhere in the United States. Plastics 4 and 5 are commonly accepted. 3 and 6, less so. But 1 and 2, absolutely try to recycle those. For the other materials, there's a lot of specialized collection facilities that might exist. So say you move and you've ordered a lot of furniture and now you have, a room filled with styrofoam packaging. Styrofoam is polystyrene number 6. What do I do with this? There's a specialized facility. There's one right around the corner, just in the valley, that collects polystyrene and can very efficiently recycle it. You just can't put it in your curbside, is the trick. Say you refinish your house and you put on new siding. Oh, well, now I have all this vinyl siding that I ripped off, plastic number 3. What am I going to do with this? There's so much of it. You're not going to shove it in your recycling bin, but there is a specialized facility for this that can collect it. These are very easy to look up because we live in a technological era. Guys, it's so easy to get help from technology on what to recycle. Our municipality has an app, Akron Recycles. It reminds you of when to put your recycling out. And if you have any questions, you can just start typing in what the object is and it will tell you what to do with it. There's a lot of resources out there in order to help you recycle properly. Just stop wish cycling. This is a term where, you have your garden hose and you think, well, this is plastic, right? I can recycle this. Don't wish that everything is recyclable because everything is not recyclable. Help our recyclers become profitable by giving them the objects that they need. And then recycling can expand its infrastructure. Because we really want to do the right thing. I know, I really want to recycle everything, but we can't. And the companies know that we want to be sustainable. Everything is sustainable these days. Everything wants to be marketed as sustainable. But it's important that we watch out for greenwashing, where companies tell us this is the green option. Look at this green object here, this green object there. A lot of times it's just marketing. Something that is recyclable is not inherently biodegradable. In fact, those are almost antonyms. If something is degradable, it's not going to be reusable and recyclable. Biodegradable does not mean it's compostable. Composting is a very specific environment with specific bacteria that operate at 60 degrees Celsius. And being degradable has nothing to do with being a bioplastic. A bioplastic just means that instead of being made from fossil fuels, it was made from a plant. But it can still be polyethylene. It's the same chemical. It just came from a different source. And none of these have anything to do with what the greenhouse gas emissions are, how much CO2 is produced. So we need to be aware that all of these terms mean different things and accomplish different aspects of our goals in sustainability. So beware, green, everything is green. We should absolutely use reusable bags. This reusable canvas bag, if you use it over and over again, you are doing the right thing and you are reducing the amount of waste. But it takes about 127 times as much energy to produce this canvas bag as it does a plastic bag. So you better use this thing 127 times. That's about 2 to 3 years of grocery shopping, depending on how often you go. And if you do that, then you are making the right choice. But if the handle breaks and rather than sew it back together, you decide, I'm going to chuck it after 2 or 3 weeks, you're not contributing to a solution. Paper bags are somewhere in between. You need to use a paper bag 7 times before you offset the emissions associated with a single plastic bag. That includes transportation, paper's heavier, all these fresh water inputs that go into paper bag. It's complicated. So should we ban plastic bags? There's a lot of talk about this. Let's ban the bag. No more plastic bags. I'm sick of plastic bag waste. I agree, but only if we ban all single-use bags. If we maintain a single-use lifestyle and we just switch over to paper bags, we're going to be in a lot of trouble. So ban all plastic bags or adopt container deposit programs. We have container deposit programs. So if you ever have a glass bottle, right, return 5 cents, Ohio, 10 cents, Michigan. If you're like me, I drive up to Detroit, double my money, right? And so that deposit program is a tax. When you bought the bottle, when you bought the product, you spent 5 cents a bottle to rent that glass bottle. And when you return it, you get the 5 cents back. Or in the case of most of us, we end up discarding them. Someone else collects them and they get the money because they might need it more than we do. But at the end of the day, there's a lot less container waste when there's a deposit program. We rent the container and we get the money back when you return it. These sorts of programs have much higher success rate and are less drastic than outright bans, right? It's just a tax. And so we should be pushing for these sorts of programs. What about bio bottles? I mentioned bioplastics are different, right? So if we look at the plant bottle, hey, it's got green arrows. That's even better than recycling, right? This is made out of a plant. It's a 30% made out of plant, but it's still PET. The environment doesn't care whether this polyethylene terephthalate or this polyethylene terephthalate, where it came from. It's the same material. It's the exact same material. And if we think about how these are produced, this is a study from the University of Minnesota from Chen's group in 2016, where they look at the life cycle assessment. They look at every single step in the manufacturing of a traditional PET bottle. That's this section here. Polyethylene terephthalate is made from a fossil fuel known as paraxylene. Paraxylene is subjected to a series of reactions. You have to transport it, and eventually you get the terephthalic acid of polyethylene terephthalate. The ethylene glycol is what's the 30%. So you take ethylene, which is natural gas, turn it into ethylene oxide, ethylene glycol, and then you transport that to make the polymer, the PET. This plant bottle is the exact same process, except you've added steps to it. Now, in order to get to xylenes, rather than just extract it, we have to take biomass. We have to refine the biomass through a pretreatment, a hydrolysis, and then a fermentation and transport that. Same thing with the ethylene. We go from ethanol, so a distillery, and then form the ethylene. So we just add steps. Adding steps is certainly not going to be more efficient from an energy standpoint. And so Chen goes on to look at the difference between PET and bio-PET. In this case, what we're looking at is we have fossil fuel material. So brown is fossil. You can also make this material from corn waste. So when we harvest the corn, we get the vegetable, but then what happens to the stalk and the roots and all that other waste? Well, we can turn that into chemicals. Switchgrass is a plant that we would grow intentionally for chemicals. It grows really, really quickly, so we can produce a lot of it. And then wheat straw is material that grows in the forest bed. And so when we clear forests and we do forest management to try to prevent forest fires, what happens to all of that waste? So if you look at these, you can see the different impact categories. So how much CO2 is emitted? Fossils best. How much acid and acid rain is released in the process? Fossils best. What about human health particulates, things that cause asthma? Fossils best. Smog, how much ozone gets released? Fossils best. Eutrophication, Lake Erie, right, has these algae blooms regularly. Huge problem for our region. That's called eutrophication. How much eutrophication? Fossils best. Ecotoxicity, how much toxic chemicals get released? Fossils best. What about depleting the ozone layer? Fossils best. The only one impact category where fossil fuels do not outperform is fossil fuel depletion. So how quickly are we going to run out of our fossil fuels? This is the one area that bio-based materials excel at. This is complicated. This is really complicated. How do we do the right thing? This is the problem we see. Plastic waste. It's tangible. It's expansive. I hate it. We all hate it. But there is an invisible problem, which is orders of magnitude worse. Plastic production accounts for 5% of what we do with our fossil fuels. Another 5% is spent making solvents and chemicals and pharmaceuticals. 90% of our fossil fuels are incinerated for energy, generating greenhouse gases, carbon dioxide. When I was born, fossil fuels were at 350 parts per million in the atmosphere, or carbon dioxide, I mean. When you were born, it was a little bit higher at 375, and it has been exponentially increasing. This only goes back to the 60s. I see that Barry's on the call, so we got to extend this a little bit back, huh? But these fossil fuels, if we look all the way back to the Industrial Revolution, this is even more dramatic. So as much plastic as we see, there is 20 times that much CO2 in the atmosphere every single year, okay? It's an invisible problem, so it's easy to ignore. But it is the most vital threat to our sustainable lifestyle. And that's because everything needs energy. Our society for millennia relies on oxidizing carbon to CO2. When we would build campfires, we're turning carbon into CO2. When we adopted the coal power, we started turning carbon into CO2. Fossil fuels and gasoline is carbon into CO2. This is combustion. Our energy and our carbon emissions are linked. We have a carbonized energy system. This is the problem. This is the most vital and pressing issue to our sustainability objectives. Unlinking carbon and energy. We must decarbonize our energy system. This is from the Paris Climate Accord. We need to decrease carbon emissions. If we do this immediately, we start decarbonizing our energy system, we will observe a temperature overshoot. So we don't want to decarbonize, see that climate temperatures are still going up and then say, oh, it's not working. No, we need to push forward. There's going to be a lag, an overshoot, and then we need to adopt negative emission technologies where we actually are sucking CO2 out of the atmosphere in order to run energy. And we're getting there. We have biomass, wind, solar, hydroelectric, and nuclear are all important technologies. But what you can see is as we've been adopting these technologies, we just are adding them on. We're not supplanting oil, coal, or gas. We're just adding these new technologies. And in part, that's because these negative carbon emission technologies, they're not scalable. They're not working very well. So we think of ideas like fertilizing the ocean, literally having intentional algae blooms so that we can collect that carbon, that algae, which is sequestering the CO2. If you've heard about ocean acidification, that's because the CO2 is dissolving in the ocean, forming carbonic acid. It's literally like seltzer water in the ocean. It's acidic. If we add base to the ocean, then we can sequester more CO2 into it. I'm a little nervous about trying to dump a bunch of chemicals into the ocean in order to suck CO2 out of it. Doesn't sound like an inherently good idea to me. Can we bury the CO2? None of these technologies are really scaling. The best one really is reforestation. Plant more trees. So there's been a couple revelations. Hopefully you've learned some things, but there's been a lot of downers. This is a little discouraging, right? What I want to emphasize is that there is light at the end of the tunnel. There is a success story here, both figuratively and literally. There is light. Photosynthesis is the most time-proven and efficient method for nature to sequester CO2. Photosynthesis fixates billions of tons every single year of CO2 into carbon. That's significantly more than the amount of plastic that we make. So let's come back to this bottle. I may have been a little hard on this bottle before, all right? This plant bottle, although right now, emission-wise, it's not the best idea, eventually it might be. Because emissions are harsh on this plant bottle because fertilizer emits a lot of CO2 when we produce it. The transportation of this bottle emits a lot of CO2 to transport it, et cetera, et cetera. But as we decarbonize our energy system, as we adopt wind and hydroelectric and all these carbon neutral or carbon negative energy sources, the amount of CO2 that's emitted per kilogram of the polymer starts to decrease. So this is work from the Grantham Center. And what they have found is that there is a breaking point for every single plastic where the bio-based material relative to the fossil fuel-based material, they cross. What that means is that on the other side, when we've decarbonized, we're actually pulling more CO2 into the material than it took to make the material. The plastic becomes carbon negative. So what does that mean? This is where we are today, right? Lots of landfilling, lots of leakage. Well, if we start landfilling bio-based plastics with a decarbonized energy system, that's carbon that was in the atmosphere, and now we've put it in the ground. We've sequestered the CO2. Hundreds of millions of tons of plastic sequestered every year. Material that leaks into the environment, we're getting really good at making degradable plastics. Plastics that only last for a couple months as opposed to centuries. I showed you some results from our lab where we're very interested in how to make recycling more profitable. That way, instead of just having a sliver that is profitable, this whole slice of the pie is now high value plastic. And incineration, well, we're getting really good at depolymerizing the plastics, turning them back into the fossil fuels they started as. So all that plastic waste that's in the ocean or in our landfills, we can start to collect again and break back down into what I call neo-fossil fuels, the next generation of fossil fuels. And so where I see us today, I think we are very much so on the way to a sustainable future. We need technological advances, we need policy advances, and we need behavioral advances, both from individual consumers like us, but also from companies as well. So with that, happy Earth Day. This is my favorite photo of the Earth, courtesy of NASA's Voyager, the pale blue dot. And with that, let's open the conversation and be happy to answer any questions you guys might have.
Thank you very much, Dr. Eagan. I will work on unmuting everybody so that you can use that feature if you would like to. But while I am working on that, I'm going to turn it over to one of our students who's also part of the Student Engagement Guide program. She has a question that she wants to ask of you. Nina? Nina, you muted yourself.
Can you hear me now?
Yes. Hi, Nina.
Okay. Hi. So this was such a wonderful presentation. Thanks so much for spending your time with us today. My question was, how can college students be more sustainable, and how can we help convince people who don't necessarily believe that recycling and don't necessarily believe in
Yeah, so I'm going to tackle the last half of that. How do you convince or talk to people who have who are skeptical of sustainability or recycling? And I don't believe that anyone wants to see the world burn. The Captain Planet supervillain doesn't exist, but there are people who prioritize the economic factors. We need to have a thriving economy. If people don't have jobs, then there is no sustainability. And so people will prioritize the economics. And what I would point to is to really emphasize that you need to have a financial conversation with them. There's green, being sustainable, but then there's also green, which is just making a profit. And as sustainable technologies become profitable, then they will start to win out. So they need to be the pragmatic choice. They can't simply be the happy-go-lucky choice. And I would also point to the fact that we subsidize our traditional way of life a lot. We pump a lot of subsidies into fossil fuel industries and plastic manufacturing. And redirecting some of those, or just having a freer market, could be an appealing way to communicate with those sorts of people. In terms of how can college students be more sustainable, you can really only take accountability for your own actions. So for me, I use a reusable water bottle. I have had the same cell phone for pushing 8 years now. We need to reduce our need, consume lifestyle. That is the most important thing that we can all do to improve sustainability.
Thank you. Amy, I think I see your hand up and you posted in the chat.
Yes, I have a couple of questions on microplastics and what do you think is like, I'm teaching younger, I guess would be scouts, and they're stuck in the same sustainability pamphlet for a long time now. And I'm trying to explain to them microplastics, and also a lot of people are pushing robotics, and there's a lot of e-waste. And I was wondering your thoughts on that as well.
Sure. So let me share some microplastics real quick. So what are microplastics? Microplastics are just telling you the size of the plastic. In fact, this image here that they're showing where there's a button and some springs, these are not microplastics. These are milliplastics because they are not micron in size. And so a microplastic is a very small micron-sized or smaller plastic. One of the things about microplastics to remember is that not all plastics are the same. Plastics is a catch-all term. It does not mean the same thing. We put a lot of plastic in our body, right? So this research article here, there's plastic in our bodies. There's plastic in our table salt. There's plastic everywhere. That doesn't tell us what kind of plastic it is. So we put a lot of plastic in our body. Polypropylene, for example, is a common surgical mesh, and that surgical mesh will degrade over time. And we have microplastics in our body that we intentionally put there, and we know by the FDA that they're safe. And so some plastics are not a problem in our bodies. Other plastics are not good. So this is where microplastics come from. Microplastics often come from our fibers, so when we do the wash. And so I often use the analogy of if you run your dryer and you have your lint trap and you collect your lint at the end of your dryer, right? And you take it out and you throw it away. That much lint also came off in your wash. And where did it go? Straight into the municipal water supply. And so there are lint traps that you can install on your washer in order to do your part to collect it. But at the end of the day, a lot of microfibers are contributing to the plastic breakdown. Here at Akron, we're tire capital of the world. Tires, tires, tires. Major contributor to microplastics. And this is where tire debris probably is not a good microplastic for the environment, because tires contain much more than just a plastic. We have all sorts of metals and additives and compounds in the tires that then are left. Every time you replace your tread, right? Your tread goes bad after 5 years. Where'd that tread go? Well, it leached into the environment. And so when it comes to microplastics, and this starts to segue then into marine waste in general, some of it's micro-sized, some of it's large, vehicle tire dust is a major part of that. And so tires that are less impactful on the environment are a very important part of developing. And the tire companies are looking at this. They are not, ignoring it by any means. When it comes to the ocean, though, 50% of the waste in the ocean is associated with getting food out of the ocean. And so fishing nets, when they get lost, that is a major source of microplastics. These are made from nylon and polyester. And so plastic in the ocean, about 50% of it is marine associated materials. And this gets to the last slide I want to share here, which has to do with an effect called ghost fishing. And this is a pretty sobering slide. Ghost fishing refers to a net when it gets lost. No fisherman wants to lose their net, but when they do lose their net, there's no protocol for reporting, hey, this net is lost. So a lot of nets, either historically or currently, have been lost at sea. Well, they are still nets, they still catch fish. Those fish are going to strangle eventually, and they will eventually die. And then that's going to attract other creatures to come to the nets, and then those, and so eventually the net becomes so bogged down with animals that it sinks to the bottom of the ocean. It then gets scavenged or decomposes, and the net's still intact. So the net gets liberated, and the cycle continues. And so there are wonderful organizations that are dedicated to breaking this cycle with human intervention. They go in, they catch the nets, and they pull them out.
Amy, if you had a follow-up, you can. And we'll open up to others as well.
Yeah, for the nets, if they can make a nanobot satellite or tracker, why can't they put it in the nets so they can find where these are breaking off at?
That would certainly be an option, right? One of the trade-offs there is that becomes an expensive net.
All right, Cassidy's ready to go.
And it wouldn't do anything for historical nets. It would be just as effective to probably establish a protocol where if you lose your net, you report it, and then the intervention team can go after it. The hard part's finding the nets. The ocean's a big place. But yeah, tracking technology would certainly be a viable option. Yeah.
Do we have questions from anybody else on our call today? Dr. Eagan, can you share if you have some ideas of some resources that we can explore to continue to learn more information? I think you had mentioned the Akron recycling app, which I did not know that existed, so I appreciate that. Do you have other? Go ahead. Thank you.
Yeah, I should have added that to this slide here. And so the name of that app is Akron Recycles. So luckily it's easy to find in most app stores. But some additional resources I'll direct you to is the REWorks. REWorks is a local organization that is on the ground. They're the boots on the ground trying to educate people on, hey, you can't put this in the recycling bin. And so they're really doing the outreach on the ground, going around neighborhoods to try and improve recyclability. If you are more on the industrial side and you want to see some of these larger scale projects, the Alliance to End Plastic Waste is a multi corporation group that is dedicated to trying to address some of these challenges, and they have both updates but also funding opportunities. Some of the studies and information I presented came from the Grantham Center for a Sustainable Future at the University of Sheffield. And if you want to dive into some of the investigative reporting and some of the juicy details, this Plastic Wars is a documentary that's really well produced and very insightful, and it's free, available both on PBS as well as YouTube. And then we have local organizations. So Zips Precious Plastics is a student group for us at the University of Akron that are building the equipment for complete recycling facility, essentially. And it's meant to mostly be an educational tool. Hey, this is what goes into it. And we've done little things like I have my my Zips logo necklace that I made out of recycled materials that were ground and then compression molded, for example. And so there's lots of fun resources and groups on campus as well, if you're interested in getting involved. Let's see if I can show this a little better. Yeah, there's our necklace that we made.
Wonderful. Are there any other questions from our audience today? Dr. Eagan, is there anything else that you wanted to share that we didn't necessarily get to?
Yeah, I think Marilla had a question.
I'm sorry. Go ahead.
Yes, thank you for your presentation. It's very informative, and as someone who doesn't have the scientific background, I'm just curious. I'm a child of the 70s, 80s, and I remember that before the plastic invasion, I was born in a developing country, and I remember in Central America we had, and I was wondering if commercial companies can go back to doing this. Get the instead of using plastic, why don't they use bottles like we had to recycle? I remember we would have to go and buy Coca-Cola in a bottle instead of, and I will remember that they would need to be clean and we would need to reuse them. Would that be an impediment, economic impediment to those companies? That's why they're not doing that?
Sure. So there's some push in that direction. There are zero waste companies specifically for things like shampoo and soap, where you have the bottle, you get your product, you send the bottle back, and they refill it for the cost of just the soap. And there are stores like this as well. Zero waste stores and zero waste lifestyle. When it comes to the larger scale bottle issue, for example, plastic is really light and glass is really heavy. And so you can transport a lot more product with a lot less fossil fuel gasoline than to move a glass bottle. So there's an economic and an environmental incentive to not use glass in a lot of these applications. You're right, though. That's the invisible problem, right? The CO2 emissions that we don't see. We see the plastic waste. And so it's tricky, but we should just be reusing the plastic bottles at the end of the day, is my take on that. Bring back the milkman, essentially, right? That is what we need to do.
Well, Dr. Eagan, was there any final thoughts that you had that you wanted to share? I thank you very much. This is very, very helpful information. I'm not well versed in this topic at all, but I really did take away a lot, and I did take some notes throughout this as well. So I appreciate it.
Yeah, just don't get discouraged by it. Recycling might not be where we want it to be right now, but it doesn't mean that we should stop.
Yes, I will be posting the recording on our University of Akron YouTube channel, and I will send the link out to everybody who was a part of today's call, just so that you do have access to it moving forward. So once again, thank you very much, Dr. Eagan. I do appreciate your time and the information that you shared with us today on our topic of plastics and sustainability. I think you mentioned at the beginning of the call, I know Earth Day is actually this Thursday. We should celebrate the Earth every day, not just one day. So also in University of Akron, we are encouraging our students. We did create a week-long challenge that if you look in last week's zip mail and then tomorrow's zip mail, you'll see the different opportunities that you could take that you could take advantage of virtually this week, just to help continue to bring the focus to sustainability and our Earth, at least this week, to try and do our part, as small as it might be. But you could look for that information in your zip mail. Again, it will be out tomorrow. It was also in last week's as well. So once again, thank you very much, Dr. Eagan, and thank you to everybody who came to this conversation. I appreciate it, and I hope you all learned as much as I did. So thank you.
Thank you, Billy. Thank you, everyone.